Okay, so what we are going to do now is to find the Jordan form of a matrix using only the characteristic polynomial and the minimal polynomial of a matrix. So here it is. Those are the data we have. We have the characteristic polynomial x minus 1 to the power 4, x minus 2 to the power 3, and the minimal polynomial of the same matrix, x minus 1 to the power 3 and x minus 2 to the power 2. Now, the question is, how do we find the Jordan form of the matrix related to this? The first thing that we note is that this matrix must have a Jordan form because the characteristic and minimal polynomial are divided to can be factored into linear factors. So we have a Jordan form. Um, and now, from the characteristic polynomial, we can understand for each eigenvalue, the first eigenvalue is 1 and the second is 2, we can understand what is the sum of sizes for each eigenvalue of the Jordan blocks. For 1, the power of this is 4, so the sum of blocks should be of size 4. And for eigenvalue 2, the sum of blocks is of size 3. Now, if we look on the minimal polynomial, what it tells us is what is the size of the biggest Jordan block for this eigenvalue. For example, for x minus 1, which means for eigenvalue 1, the biggest size is 3. And for eigenvalue 2, the biggest size is its power, so it's 2. So we know that for 1, the biggest Jordan block is 3, and we know that for the sum, we have sum of blocks for eigenvalue 1 of 4. So it must be that one of the blocks is of size 3, and what we have left is 4 minus 3, which is 1. So the second block for eigenvalue 1 is of size 1. Now for eigenvalue 2, we have the biggest block of size 2, and we know that the sum of sizes of blocks is 3. So we have a block of size 2, and 3 minus 2 is 1. So we have another block of 1. So we can know all the blocks we need. So again, for eigenvalue 1, we have minimal polynomial tells us that the biggest block is of size 3. Here it is. And what we have left is to sum it all up to the characteristic polynomial. So we need another block of size 1. Here it is. And for eigenvalue 2, we have this block because the minimum polynomial said that the biggest block is of size 2. So here it is, and we need to sum it all up to the power in the characteristic polynomial, which is 3. So we need another one. So this is the second block. So here it is. Now we just put it in a matrix like that, and we open it up, and we have the Jordan block of this matrix only by knowing the minimal polynomial and characteristic polynomial. Of course, it's not always that easy, but this was a case that we can do that. So we practiced a little bit how to look on the characteristic and minimal polynomial in relation to the Jordan form. Thank you all very much. Thank you for watching, and that's it.